Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Eriko question number 1175, prime arrangements. Return the number of permutations of 1 to n so that prime numbers are at prime indices. And one index is the array. Okay. Since the answer may be larger, return the answer modulo. Okay, fine. So they are asking us to find how many ways we can arrange them. Okay, fine. See here, what is maybe prime number at first? What is maybe prime number? Okay, a prime number has only two factors. What are they? One is 1 and y itself. So it is called as a prime number. Okay, let us take 5 as an example. 5 has one factor and another factor is 5. And similarly, 7 also has 1 and also 7. Okay, let us take 10. It has 1, 2, 5 and then 10. So it is not a prime. So this is how we will find whether it is prime or not. Okay, now coming to the question, they have asked us to find if n is equal to 5, then how many permutations we can make if prime numbers are only placed at the prime indices? What is maybe prime numbers can be only filled with the prime indices? Okay, let us take if n is equal to 5, what are the numbers present? 1, 2, 3, and 4, 5. So these are the numbers we can say between them. Okay, let us write in an array 1, 2, 3, 4, and 5. Fine. Now, just listen this. First one is 1, right? 1 is not prime. 2 is prime. 3 is prime. 4 is not prime. And 5 is prime. Fine. Now, using this, see here. Here, 1, 2, 3, 4, 5 are indices. Same indices, okay? In first index, I can put what are the numbers? It is not prime, right? Because of its not prime, I can put 1 or 4. At this 2, what can I put? It is prime, right? So I can put 2, 3, and 5. And this prime, I can put again 2, 3, 5. Here, I can put only 1 and 4. Here, I can put 2, 3, 5. Okay, by doing such permutations, I can get what is the result? 12. So how will my permutation looks like? Something like this. See here, this is how my permutation looks like. Can you understand? Yes, see here, these are all the possible permutations we can make. 1, 2, 3, 4, 5. Then I just wrote the all 12 permutations. Okay. Now, how to solve this question? So, do we really need this? Do we really need this? No, right? We don't want to generate all this. We want only count. We want only count. Okay, let us step into this approach. See here, if I have m is equal to 5, then 1, 2, 3, 4, 5. Fine. Now, what are the indices are prime and not? So, I can say this is prime, and this is prime. And similarly, this is not prime and this is not prime. Okay. So in non-prime indices, we can place only non-prime. In prime indices, I can place only prime. Okay. Let us take only not prime. See here, these are the two indices. Just take for example. I can place either 1 or I can place 4. So here I can place any two number. Here I can place only one number because one number is already placed, right? So it will be a combination of 2 into 1 which is equal to 2. Hope you understand, right? Now, similarly, take for example, if it is prime, it has 3 values, right? Okay. What are the values I can put in this? I can put 2, 3, and 5. So here I have 3 ways. Here I have 2 ways. Here I have 1 ways. So this will lead to what? 3 into 2 into 1 which is equal to 6. So this can be written as 2 factorial. This can be written as 3 factorial. Can you understand how we build a relation? Yes. Okay. Now we have built a relation for individually. This whole relation is for what? Not prime. And this whole relation is for what? Prime. Okay. Now we want to combine these two, right? We want to combine these two. Okay. If we combine these two, see here, just take for example, how many ways we can write only the prime numbers? We can write totally 6 ways. Okay. 6 ways. So there are already 2 ways we can write and not prime. So if I multiply this 2 and this 6, I can say how many total ways I can write. So just multiply 2 factorial into 3 factorial, which is equal to 6. sorry, 6 in, sorry, 2 into 6 is equal to 12. So 12 is my answer. This is my output. Okay, my friends, right? Now, it's time to see the first step. We are doing what? Yeah, we are just saying the approach. Now, it's time to check whether, how to check the number is prime number or not. Okay, how to find whether the number is prime number or not. It is so simple, right? See here, if a number like 10, okay, if 10 is the number, then I will take from 2 to square root of 10, okay, as I, and if 10 mod I is equal to 0, then I will return what? False. That's it. So this is the method to find the prime number. Okay. If n is equal to 10, if n is equal to 10, I have to transform what? 1 to 10, and in each 10, if this is the prime number function, right? I want to do this prime. Okay. So it will lead to something like n into maybe a square root of n as a time complexity. So this is my time complexity, right? So my time complexity will be what? O of n into square root of n. Okay. Can we reduce this? Because this step cannot be reduced because it is already optimal. We are only finding what? Factorial here, right? We are only finding factorial here. Okay. Shall we reduce in step? Okay. We have a method called sieve method. Full form is sieve this method. I don't know how it is right, but it is a sieve method. I will tell you the algorithm. This algorithm is very, very super duper. See here. I will tell you. Now, see this example. N is equal to 25. Okay. Then I will put a array size of 26 ranging from 0 to 25 in this and make every value as 1. Now, just here. Whether 0 is prime? No. Such that I will change that 0 as 0 and this 1 as 0. This is the initial step we want to do. Now, I'm going to traverse from 2. Okay, I will take this 2 first of all. What is the value of this 1, right? It indicates what? 2 is prime. 2 is prime. Okay. If 2 is prime, then 2's multiples are not prime. So I will make them as 0. So make this as 0, make this as 0, 0, 0, 0, fine. Then next, I will go to this 3. 3 is whether 1 or 0, 1, which means it is prime. Then 3's multiple should be a not prime, right? So make this as 0, already is 0. Now make this as 0, and this is already 0. So make this as 0. Then 18 is already 0. 21 is not 0. So make this 0. And 24 is already 0. Fine. Now again, I'll go here. Whether force value is prime? No, it contains 0. Okay, okay. Then go to the next value, 5. So 5, so I go back to this 10, that is already 0. 15 is already 0. 20 is already 0. 25, 25 is not 0. So make this as 0. Yeah. Now, if I take this 6, if I take this 6, whether it is 1 or 0, 0, which means it is a now prime. Okay, then take 7. 7 is prime, right? Because it's just 1. Okay, go to 14. No. Go to 21. No, already it is marked. Okay, no. Go to 8. No. Go to 9. No. Go to 10. No. Go to 11, which means what? It is prime, right? Go to 22. 22 is already 0. So no, we don't want to do anything. Okay, take 12. We don't want to go. Take 13. 13 is what? 1. Okay, so it is prime. So 26. There is no more 26. Okay, then we should stop here because it is out of array. Now, do you observe that after this 5, for this all these values, I haven't done anything right. So my end points would be up to this 5. That's the first observation. So first observation is that I have to traverse from 1 to, if it is 25, then square root of 5. So this is my first observation. Okay. What is my second observation? See here, I started from 2. Okay. For 2, where is my starting point? For 2, my starting point is 4. For 3, where is my starting point? It is 6. 6 only, but 6 is already done by 0 by 2, right? So we started from 9. So for 3, it is 9. Okay. For 4, where we have started for 4 like 8, but 8 is already done. 12, it is already done. So we gone back on to 16. 16 is the first piece, right? So it's similarly for 3, it is 25. So from this, we can say the starting point of changing a 1 to 0 will be what? I into I. Okay, can you understand this? So this is the optimal approach. So for doing this approach, we only take a time constant and space of t plus space of t is O of n. Okay, definitely this O of n. If that is our n elements, we want to take this. And time constant will be O of n into log of, okay. So this is very negligible. Okay, and this n will be a majority. But you have to write this. Okay, so this is my time and space of the analysis. Now, by using this, we can apply that, right? See here, by using this, we can apply that means, just see here, if I find prime numbers, it will be like 0, 1, 2, 3, 4, 5. If n is equal to 5, then my count will be like, this is my array, this is my prime array, this same arithmetic method. See here, it will be 0, and it will be 0, and it will be 1, 1, and it will be 0, and it will be 1. By using this, I can say my prime number count will be 3, and non-prime will be only 2. We don't want to take this 0. Be careful, don't take this 0, okay? Okay, I can say this. Then I will take 3 factorial into 2 factorial. I will return this. How to find the factorial? It is simple. Just make I value iterate from 1 to n and take any variable and into is equal to 3. Then return that variable. That's it. Fine. Now we came to the end. Now it's time to see the code. See here. Mod is equal to 10 power 9 plus n. This is a question requirement. Other than that is nothing. Now, say the fact of n is equal to 1 for I in range of 1 comma n plus 1. So I'm passing from 1 to n and I'm just multiplying and mod by this mod value. Okay, now I'm returning it. Fine. Then prime is equal to n minus 1 for I in range of 2 comma n plus 1. Okay, I'm just passing from that 2 to n plus 1. Now for I in range of 2 comma int of which means the square root. I'm taking the square root and if any number that divides this I value, then it is not a prime number, right? So I will minus 1 in a prime number. If I, you may ask, why we are doing n minus 1? If n is 5, then why I am taking initially as a prime number is 4? Because 1 is not a prime number, right? That's why I just took what? N minus 1. And here I just traversing from what? 2 to n plus 1. This means what? 2 to 5. Not taking that one. That's why I just exploded here itself. Then I keep on exploding here. Then return fact of prime into fact of n minus prime and 1. That's it. Let me submit it. Yes, it is submitted actually. Now it's time to see that optimized solution. See here, this is the optimized solution. Same thing, this fact function, but here num is equal to n plus 1. Okay, which means if it is n is equal to 25, we want to create an array of size 26 as a 0 to 25 indices. Okay, now initially prime is equal to 1, which means everything is true, everything is prime. Inside assumes everything is prime. Now prime of 0 and prime of 1 is equal to count is equal to 0, which means I'm just initializing 0 and 1 to 0. That's the first step, right? Now, for I in range of 2 to square root of n. Okay, and if that is prime, if the current I value is prime, then I have to traverse from what? I into I, which means if it is 4, then I have to traverse from 16 to the end. There is something what? 4 values, like wait, I into I, comma, num, comma I. You can understand this, okay? And I will make them all as what? 0. Because they are multiples of prime. So there will be not a prime, right? And then count is equal to 0 for I in range of 1 comma none. And if prime of I is equal to 1, then I will count this. Usually one, I just keep on going on. And if it is 1, I will take this as a count. Fine. At last, I will just written what? Count into a factor of n minus count. Let me submit it. Yes, it is a bit of. Thank you.